Okay, so we may start. This will come on week 3 on our code to solve challenges.
Okay, good, everybody. I want to know, can you see my screen, please?
I think your volume is very low. Try to, yeah, I can see your screen. Try to raise your voice.
Okay, can you see my screen now?
Yeah, I can see your screen. I can see your screen.
Can you hear me too?
Yes.
Okay, so the assessment given to us is to check. It's about the swap case. And so the question is, you're given a string and your task is to swap cases. In other words, convert all lower case letters to uppercase letters and vice versa. For example, this input we have to take. This should be the result. You look at it. So the swap function, basically what it does is that it returns a string with all upper cases and converts it to a lowercase, and lower cases it converts it to uppercase. So I will do that on my VS Code if that's okay.
It's okay.
Because I've already done it on this one. So first of all, we're going to create a function. Give it a name, swap case. That takes in a parameter. And also we're going to initialize an empty string. An empty string. So this variable is going to hold the new swap case, the result. This is what we're going to print at the end. We're going to loop through the argument, the parameter. What this is doing is looping through every character in this word. To check it, to check if every character is upper. Then say change word. Change word. Equal to upper. So what this is doing is checking if the character is upper, then change it to lower. If it is not, it changes it back to upper. Change word. We're going to call the function. So here it could be let's do it like this. So let's print it out. Can you see what it did here? Change every character to uppercase. The lowercase, it changes it to the uppercase, it changes it to the lowercase. The lowercase, it changes it to the uppercase. So this is how I came about it. Just like what is there, what is here. So here they've already given us the input, which is the hackerrank that's come in this mix of swap cases. So for us to change it also to another mix of swap cases. And so we had to return this swap case, and which we printed. So when you run the code, you can see this is the output that was given, and this is the expected outcome. If you look at it, it's the same thing. Yeah, this is the input, and this is the output. And this is what is expected. So that was how I was able to do it. Hello?
Hello, that was nice. Thanks, Semi. Tawa, do you have any question? Look like all of us were good. Did you manage to? Oh, it's only two of us.
Huh?
Is it only two of us? Or
Only what?
I think Tao is here. I thought it was only two of us.
No, I think there are Taiwo. Oh, it's just the two of us. Oh, I don't know. Taiwo is here, but I don't know.
Yeah.
It doesn't. I don't know. I can only see myself here. I don't know.
Should I do mine?
Yes, if there's no questions, no problem.
Yeah.
Thank you.
So, thank you very much for your.
Evening, everyone. It's Hamid done.
Yeah, Shamil is done. So I'm not sure.
Okay.
I'm not sure if it's
Apologies
how.
for missing out on your presentation again.
Huh?
Apologies for missing out on your presentation. I had network issues.
Yeah, network can be funny. So we just did swap case. Where was it's a function where we change a lowercase to an uppercase and uppercase to a lowercase. So this is we have been given an input already, which is this input here, and so the expected output should be this one here, as you can see. And so it has been given to us here, and all we had to do was return it, and it prints out the result. So what I did here was that I created a function that takes in a parameter word, and created an empty string, then loop through this word to see if each character, if a character is upper, and if it is, then it prints out. You had it. You change it to a lower and put it into this empty character. Else you change it to also if it's lower, then you make it upper. So we now like I printed the new swapped characters and call the function. So when I put the string here, this is the result here. So for instance, if I put your name here and something, that comes up. You can see this is what a function swap case does. It changes each character to the opposite. Understand? Lower to upper, then upper to lower. Thank you. Okay, thank you very much.
Thanks. Did you check the efficiency of it? It looked like the code is very fast. Did you check the efficiency?
Yeah, I think I did. It worked on. I think the time complexity was a linear time complexity. Big big of n.
Okay, thank you very much. Alfonso, do you have any question?
No questions from me.
All right, thank you.
Okay, cool. I think I should, because that was also Tewa did not have any questions. Let me share the screen. Hello, can you see my screen?
No, not yet.
Okay. Can you see my screen?
I can't see your screen on my side. Sorry.
Because I stop and reshade it, so I'm not sure.
No, it's blank here.
Still not clear. You can see.
I shared the image on WhatsApp. That's what I'm seeing. I can't see anything.
Okay, let me try and stop again. Stop.
Mine is blank. Did you share anything? What's happening?
Yeah, I'm trying to share mine. I'm not sure it is my site network or what.
Okay.
Can you see my screen?
I cannot. I don't have contact access to see your content, something like that.
Still nothing.
Nothing. The last time when he tried showing me something, he said I don't have access to view your content. So I don't know why. Maybe I'm restricted. So But right now, I cannot see anything.
Still nothing.
No, I don't know. Is God saying something on Taiwan? On my side, no.
Let me try and log out and come back. Hello, everyone. I'm back. Okay, let me share the screen again. Can you see my screen? Okay, thanks. Sammy, try to log out and come back. Maybe I think it's your network your side.
What do you say?
Try to log out and come back because maybe it's your network on your side.
Okay.
Let me start. Okay, we are giving a challenge the maximum odd binary numbers. You are given a binary strings, which is our list, that contain a list, at least one string, which is one. You have to rearrange the bit in such a way that the resulting binary numbers is a maximum odd binary number that can be created from this combination. Return a string representing the maximum odd binary number that can be created from the given combination. Note that the resulting can still have leading zeros, e.g. let's say the input that was given to us, which is S, is a 0, 1, 0. The output should be 0, 0, 1. These binary numbers 0, 0, 1, 0. This is an even number because it had a 0 at the end. So you need to find the maximum odd number. In binary numbers, the odd numbers start with 1. So from the start, from the right side, you have to have 1 and also have a binary number. And this is an expression because it's just only one, which is this one. It must be at least last position. So the answer is 001. If it's 0101, and this is an odd number, but you need to have a maximum, the highest number. I put which is 10 or 001, which is the peak number. Let me try to explain the binary. Binaries from a computer point of view. Binaries from the computer point of view are, let's say this is binary number 0, 0, 1, 0. So to convert this to, it should give us an even number. To convert the two decimal numbers, the normal number that we know, like 1, 2, 3, 4, 5. So you calculate a binary number, say, because this is 0. So you start from, because binary number has a base of 2, decimal number is a base of 10. So we're going to say 2, start from 0, this is 0, times this 0, this first 0. And then you add plus 1. This is one binary number, so you say 2 to the power of 1 from 0 to 1, and then times 1, this 1. And then you add again 0, and then this is 2, this is from 0, 1, 2. So you say 2 to the power of 2 times this 0, and then the last 0, say 0, which is plus 0, and then 2, and then times 2 to the power of 3. So we have 0, 1, 2, 3. So now we're calculating this, and then 2 to the power of 2 to the power of 2 to the power of 0 is 1. 1 times 0 is 0, plus 2 to the power of 2 is 2. 2 times 1 is 2, and then plus 2 to the power of 2 is 4. 4 times 0 is 0, and then plus 2 to the power of 3 is 8. 8 times 0 is 0. So this number is 2. So 0012 converted to a normal number, base decimal number, give us 2, which is an even number. So to convert to have an odd number, you need to have 1 here. So let's say 0, 1, 0, 1. Again, also we start here, say this say 2, because binary numbers are based on 2. 2 to the power 0 of 0 times 1. This one is first one, and then you say plus this 0 times 2 to the power of 1. Say 0, 1, 2, and then plus this 1 times 2 to the power of, we said 0, 1, this powers. So 0, 1, 2. So 2 to the power of 2 times 1, then plus the last 0, 0 times 2 to the power of 3. So we start from here. 2 to the power of 0 is 1. 1 times 1 is 1. And then we say plus 2 0 times 2 to the power of 1 is 2. 2 times 0, let's give us 0. We say plus 2 to the power of 2 times 1, let's give us 4 times 1, that's 4. And then this one give us 0 again, because 2 to the power of 3 is 8 8 times 0, that gives us 0. So here we're adding 0 plus 1 is 4. I mean, 0 plus 4 is 4. 4 plus 0 is 4. 4 plus 1 is 5. This just gives us an odd number, which is odd. Here, because the 0 the binary number starts with 0, that gives us an even number, which is 2. Here it gives us an odd number, which is 5. So that's how we separate between the odd number or the even number. So to memorize, and this way you can say, okay, they say 2, 2, 2, 2. And then this is the first index, 1, 2, 3. These are powers. So if here this is 0, it means this one is not here. So from after 0, from 1, 2, 3, going that side, any number that is power of 2 is give us an even number. So that's why we got an even number. But if there is this one here, so that's why we got an odd number. So that's why we separate between even and odd. So our challenges were the problem is to find the maximum, the big number, or binary number that can be obtained by rearranging the bits of the given binary string. So to solve this, we go by counting the number of ones and 0 in the input, the given inputs here. This is yeah. So we know where we're given there are 3 numbers. So how many 0 do we have? We have 0, 1, and 1, and 2, 0, and then 1, 1. So we know in that example, so we say, okay, we're using the count to count the number of ones and 0 in that given binary number. And then you contract the maximum odd binary number to make the number odd at least. Why does a echo? To make the number odd, at least the significant bits rightmost means at the right side of this binary number, which is say 1, 0, it must be a 1 at the end. And then we need to rearrange the remaining ones to total number of count minus 1 in the most significant position to make it the numbers as large as possible. To make the number as large as possible means we must make let's say we have, I don't know if my PDF has a way to edit here. Where is that? Okay, let me just go here. Okay, so to make the number big, let's say this is 0, 1, 0. Converting this to a number will be 2 to the power of 0 times 0 plus 2 to the power of 1, 1, 2 times 1, this one, plus 0, and then times 2 to the power of 2. So we have 4 times 0, which is 0, then 2 to the power of 1, which is 1 times 1. This one gives us 2. But if we take this one and swipe it, 1 this side and 0 in this side, let's say this is 1, 0, 0. Converting this number should give us a bigger number than 2, since 1 is on the left significance. So we say 2 to the power of 0 times 0 plus 0, this 0 times 2 to the power of 1 plus this 1 times 2 to the power of 2 to the power of 2. Give us 2 to the power of 0 times 0, this gives us 0. 2 to the power 1 times 0, this gives us 0. And then 2 to the power of 4. 4 times 1, that gives us 4. I mean, the number is more bigger than this one because 1 is on the other side. So remaining, so that's why they say arranging the remaining ones total to the count numbers minus 1 in the most significant position to make the number as large as possible. So to move 1 to the other side, then feeding the rest of the position with zeros. This stretches to ensure the maximum possible odd number. Code, which is done. Classification, okay, we have the method, the solution class is defined as the method, and then we have a method maximum odd number, odd binary number, which is our method, and then we're counting the number of zeros, number of ones and zero inside the method, which you count with the number of ones and zero in the inputs string s, and then we're constructing the maximum odd by number. If there is no ones, we return an empty strings because it is impossible to form an odd number if there's no one. So if there's no one, we can't have an odd number. Otherwise, place the count. We created a variable which is count 1, and then we minus it 1 in the at the beginning, and followed by the count of zeros, and end it with a single 1 to ensure that the number is odd. Let's say we have we have 1, 1, 1, 3 of 1, and then 0, 0. But at the end, there's no 1. So in order we check, okay, this, we have 3, 1, and then we take 1 here, and then put it at the end, so that you can have an odd number. On the base, in our test, we say, logic test, we say, okay, if the strings is 0, the only binary number we can form is 0, which is not odd, which is even number. If the string is 1, the only binary number can be formed is 1, which is odd, and then the maximum. So the base case is straightforward. For a string of the length 1, if it contains a 1, it is already a maximum odd binary number. We assume for a binary string of length n, we can construct the maximum odd binary number by placing all the ones at the most significant position, followed by all zeros, and ending with 1 to make it odd. Let's send this binary to the length of n plus 1. So adding to just to verify does it work in other numbers if we add another equation. So we have the count of ones, we're counting the numbers 1s and 0 in the string, and then let the C1 be the count of ones, and then C of 0 be the count of zeros, and then we check the length of the strings in n of plus 1, form the maximum odd number or odd binary number, and then to maximize the binary number, the most significant bits should be ones, and then to ensure that the number is odd, at least significant bits rightmost must be 1. I construct the binary, we will say C1 minus 1, ones at the beginning, so that we can put at the end, and then followed by the zeros of the C1s, and end with the 1 single 1, the one that we minus from here. And then this process ensures that the binary number is the highest possible value with the given constraints, and end with the ones and make it an odd. So let's, for example, for better understanding, we're giving the string s, which is 0, 1, zeros. We're counting the ones and 0. Remember, you said the count 1 is counting the ones. It's telling us there are two ones, which is this one and this one. And then the C of 0 is counting zeros. It's given us there are 2, which is this one and this one. Therefore, we contract the binary number, place 1 minus 1 at the beginning. We're taking 1, so and then follow with the zeros, which is 1, 1, 0. And then the one that we minus from the ones here, we're adding at the end, which is give us 1, 0, 1, 0. And then which give us an an odd number. Let me check here with we're giving a number 0, 1, 0, 1. Was it like this? Yes. In this number, we need to check a maximum because it's already an odd number. So now we need to get a maximum. To get a maximum, this first one here must be at the start. So it must give us a big number. If it's like this, converting this to this much so that you can see which one is big. Didn't I not calculate this one? Okay. So 0 times 1. And this just gives us 0, 2 to the power of 1 times 0. Then 2 to the power of 2 times 1. And then this also gives us 0, so I'm not going to continue. So this is 1 plus 4, which just give us 5, an odd number. And then, but if we say, taking this one to the left, 0, 1, 0, 1. So this is an odd number, but now it must be a maximum. Remember, we said they're looking for a maximum number. So we say that 2 to the power of 0 times 1, this one, and then plus 2 to the power of 1 times 0, this 0, plus 2 to the power of 2 times 0, this 0, plus 2 to the power of 3 times 1. So we have 2 to the power of 0, which is 1, plus times 1, give us 1. This gives us 0 to the power of 1, which is 2 times 0, give us 0. Plus 2 to the power of 2, which is 4 times 0, give us 0. Plus 2 to the power of 3, which is 8 times 1, give us 8. So add this one, give us 9. So 9 is bigger than the 5 odd number. So that's why we must go through that one so that you can get a maximum odd number in this binary number. Which is the resulting binary string, which is 0, which is 1001, is the maximum odd number that can be formed. Using the mathematical induction, we have shown that this project works for binary strings of any length by always placing the most significant one first and ensure that the least significant bit is 1. Calculating the algorithm analysis, counting the numbers of 1 and 0. This involve the iterating through the string ones to count the ones, which is goes at once, and then the strings of zeros can be calculated by subtracting the strings of 1 from the total number of strings, and then contracts the maximum odd binary number, place counting number -1 at the beginning. Same thing that we're doing. And then counting of numbers of 1 and 0, these steps requires a single pass through the string, so it go once, so which take us to the linear time where n is the length of the strings, and then constructing the output string creates a new string from the count involved the concatenating or combining the three strings, which is this one. You multiply 1 times. You multiply 1 times the 0. We're concatenating, we're not multiplying like a normal 0, which is how many 0 we have. We multiply those 0 and then minus only 1. The one that we need to add at the end, which take us 0, pick of count of 1 minus 1, and then minus 1. And then we also do the concatenation here, 0 multiply the count of 0, which take us pick of count 0, and adding this a single 1 at the end of this 6 pick of 1, which is constant. Giving the count of ones plus count of 0 equal to n, and then constructing the strings take us to the constant of 1, which is bit efficiency. And overall, the algorithm runs at linear time. So the peak of n. I think also it's relatively one and the same thing. And the space, time complexity is linear, and then space time is also linear, which is the code. So let me try and code. Where is it? So we're given a class name solution. What's the object? And then we have a method which is maximum. And was it maximum odd binary a reference, which is taking two parameters, which is reference, and then the x as an input. So we start by counting the numbers of ones and 0. So you see count ones, essence dot, and then this is a built-in count. Built-in count, and then the count zeros. Then counting the length of the string minus count ones if count one is equal to 0. If one is equal to 0, it should return empty. Since you cannot have an odd number if there's only 0, if there's no one. Say max odd and ones, and then we minus 1 and concatenate with the zeros, and then we add the one that we minus from here. And then this one should give us a maximum odd number. And let's create Let's create an object sent to solution. Let's say we put string 001, which is odd. Then let's see if we print solution, we're calling the objects. Then maximum binary s. I think should give us a proposed ID. You see, give us 011, so which is it's the highest odd number. So this should work. Look like accepting. Also to accepting. Okay, let's try and submit. Let's see, we got it at 40 million per second, which is very fast. So I think we pass it. So I think we're done, unless someone have a question. Hello.
Hello, Samantha.
Yes, you still can't see it.
No, I didn't see your screen all through. I don't know
Serious?
what's wrong. Serious. I shared
Yes,
it on
Samantha, I
the...
didn't say anything.
Yeah.
We were listening. We didn't say anything. I didn't say anything.
Even on my side.
Nothing.
There's nothing. It's a screenshot of showing us that we've joined in. There's nothing of your presentation that I see from my side.
I don't know. Not after I've coded this much. I'm even done, shame.
Maybe the
So you're
YouTube...
presenting for yourself.
But okay, so you have to check the the recorded video. I think the video is gonna show, isn't it? It's gonna show on my side.
Yeah, I think so.
Yeah.
Even now, we can't see anything.
And there's nothing.
Even now.
Yes, even
No.
now, there's nothing on my side.
And then what's wrong? Is it my side or what?
The only thing I see is just a blank screen, just white. So I can't tell if you have actually shared your screen or not. It's just blank. If you go through the message, I sent something about your University of South Africa. I don't know whether that's a reason. I don't know.
Just saw it now. I thought I just saw it now, and I thought maybe it was I can't see your screen. Eh? That's the one you sent.
Look at the error message I got. I sent it on WhatsApp.
On WhatsApp.
Yeah. So I don't know what that is. But I was able to join, but still I can't see your screen. So I don't know. It could be the network.
Okay. Who said you get the same error?
No, not the Microsoft one, but all I'm seeing is us joining in. There's nothing of your presentation that I see.
But here,
You can check the photos that I sent.
But here, it seems that you are showing, isn't it? That is
Yes,
show the
but
screen.
there's nothing. It's the white screen, not showing
It just end here.
Pardon?
It just end here.
Yes, I've been in the session with my screen looking like that. And I tried to rejoin and join again, but still, so I don't know.
So I thought this was showing when we were showing this. Because look like you can see. I don't know then.
I was using my phone, then I ended up using my laptop, so still it's not showing a presentation from my side.
But did you see a semi one?
Yes, the last bit I saw when she was in the HackerRank platform as well as the VS Code. Yes, I saw the last of it.
I don't know then. Maybe it's my side.
Yeah, it could be a network issue.
My network on my side.
Maybe.
It's crazy because for me it shows. You still can't see anything.
We're just seeing it now. I'm seeing something now.
You can see something.
Yeah. I see a whiteboard.
Yeah.
I don't know if
this all I was doing calculation, all of it, but here, you know,
I'm just saying something. I didn't see anything before, just now.
You can see I'm typing. I'm writing something.
You drew a circle now.
Yeah. So should I start afresh or what?
If you can, no problem. I don't know. Yes, you can if you want. Yes. Okay. But I don't know if Hanse can see it.
Hutu, can you see something on my screen?
I still can't see anything. As per the screenshot that was sent, that's how it is on my side.
Let me show you what I'm saying.
Because I joined using my laptop just now.
This is what I'm saying.
Yeah, this is what I'm sharing now.
Yeah, so now I'm just seeing your screen.
So all this calculation I was doing for myself.
Yeah.
Is that nice? I guess what should it do? Should we just check the video because still can't see anything.
Yeah, I can't see anything here.
Yeah.
Okay, let me try and rejoin again.
We don't even know if Taiwo is even seeing anything because he's not talking.
And then, I don't know, maybe he never joined, eh? I mean, he never focused because he joined, but he never talk.
Maybe he's busy with something.
You can see my screen. Huh? You can still see my screen.
Yeah, I can still see it on Leetcode now.
Yeah. I wonder what was why.
So your network can be very funny.
You know? You can see my screen?
No.
Hello?
No, I can't see your screen. I'll send a screenshot just now with Monai, but other than that, I don't see your work. Nothing at all.
So I'm gonna share this the video and then you can check it on the video. Right? I'll
Yes.
share it to comment and then check it on the video. Just have to go from. You don't have to rewatch yourself. Just have to go from my side and then I'll share the document and how it's because I don't know why it's not sharing. So all this calculation for Mahala. Okay, but I think on the video you can see it and then if there's any challenge you can reach out to me.
Yeah, sorry about that. I think it's the network.
Yeah. Okay, let me check for next week.
Unfortunately, I'm not seeing anything popping
Still.
up yet. I don't know. Yeah.
Okay. Okay, I guess you can watch the video then. Where possible.
Yeah, if you can, Sunny as well, can you please briefly explain what you did? Because I think I only caught the last part, so that I can do a LinkedIn post. Just briefly, what is it that you did in steps as well as manga? Then I'll watch the video. Then yeah, I think I'll upload tonight. Then with the YouTube link, I'll edit tomorrow, then add the YouTube link. Can I as well get the source code this session?
Okay.
Thanks, guys.
This is problem 1.
You can't see your screen again.
I'll stop. Should I share it?
Oh, okay. I thought you were. Okay. So I was trying. Sorry, I forgot. Don't say. What were you saying? You said I should share my screen again.
I think she wanted to.
Huh?
She wanted you to explain. I think something.
Okay. She there now.
Explain your code.
Okay.
Okay, I've put the problem for next week for the guys between Hoods and Tao.
Okay, can you see my screen now?
Yeah, I can see your screen.
What about Ponce? I don't know if she can see it. She's the one I requested.
There's nothing I'm seeing besides us, guys. There's nothing showing on my side. I think I have a it's a network issue.
Are you home? What? Are you home?
I'm home.
Or mom chulo? Little ring.
Smanga, it's recording.
Oh,
I'm home.
let me stop. I'm going to be tired with very much. Actually, I stop recording.